understand ARP, that is the Address Resolution Protocol. By the end of this video, you will know exactly what ARP does, how it works, and why it's important for computer networks. Yes, so let's start with the basics. Every computer or device on a network has two important addresses. The first one is actually the IP address, which works like a device phone number on the internet. And the second one is actually the MAC address, that is the permanent physical address of the device network card. Now, the main problem is that computers often know the IP but not know the MAC address. And actually, without the MAC address, data cannot be delivered inside the local network. That is where the ARP comes in. ARP acts as a translator. It actually takes an IP address and finds the matching MAC address of that device so that the data can actually be transferred to that receiver. It mainly operates between the network layer and the data link layer, and it is very, very essential for the data to be communicated inside the LAN or a local network. Now, here's how the ARP works in practice. When a device wants to send the data, it is having the IP address of the receiver, but it needs the MAC address as well. So it basically broadcasts an ARP request, like basically shouts as who has this IP address, and then inside the local network, and then the device with that IP address, actually replies. It reverts back with its respective MAC address, and then finally the sender is able to then store that information. It's able to store the MAC address of the receiver and and then finally sends the data to the receiver. So, ARP is basically here a question and answer system that happens behind the scenes mainly to make sure the devices can communicate and send the data correctly in the correct manner. Now, this process obviously is not random. It follows a particular structure, which is mainly called the ARP packet. So the ARP packet actually contains details like the hardware type and the size of the hardware, and then the protocol type and size, and then the operation code or operation type, whether like it's a request or reply, right? And of course, the senders and targets, IP, and the MAC addresses. Now, basically, this ensures that the devices know what's being asked and how to respond properly. Now, let's imagine this with the help of an example. Like, let's say there's PC1 which wants to talk to PC2. So, PC1 knows PC2's IP but doesn't know the MAC address, basically, right? So, the PC1, what will he do is the PC1 would broadcast an ARP request across the LAN, and when this PC2 will get the request, he will identify, okay, this is my IP address. So it will reply with its MAC address. And then further, the PC1 will store that MAC address in its ARP table. Every PC is having an ARP table, and then they both PCs will communicate smoothly. Now, this all happens in milliseconds, and like the user is not even able to even notice. Now, since constantly if we keep asking the same question, if we keep looking for the same IP addresses, right, then it can actually lead to things getting slowed down. Things can actually slow down. So devices always keep an ARP cache, which is a small memory where the IP to MAC mappings are mainly stored. They're mainly of two types actually. First is the dynamic entries, which are just the temporary ones that expire after some time, and the other is the static entries. These are the permanent ones that are manually set by the administrator. Now there are also some issues, ARP issues and security issues. Like there are possibilities that attackers can send fake ARP replies to trick devices and redirect traffic. So that's why many modern networks actually these days use protections like static entries sometimes to stay safe. No, don't worry, you will learn more about these such techniques in the upcoming videos. Yeah, so let's quickly summarize what we learned today. We learned that the ARP actually maps the IP addresses to the MAC addresses, and then it works mainly by broadcasting a request and then waiting for a reply by the receiver node with its MAC address, and then the device actually stores the results in the ARP cache memory for the faster communication. But it doesn't have some vulnerabilities that need protection, obviously. So yeah, that's it for today's video on ARP. If you found this helpful, give it a like, hit and subscribe, and share it with your friends. And thank you so much.